topic of discussion is vision transformers, vision language model, vision language action models, and myself, Dr. Anuradha Yankikar, the organizing team member of this particular ETTP program. So let's begin without wasting of time. In the today's session, we are going to cover these five important topics. The very first is what is the foundation things behind this computer vision. So what are the transformers? Why attention is replaced by new custom transformers? What is evaluation? What are the vision transformers, vision language, and vision language action? So let's start. So this is just a icebreaker session, and initially for 5 minutes we will have a demonstration of what is meant by computer vision. Those who are not from the background of this AI or computer science. So this is just 5 minutes demonstration on what is computer vision, how it actually learns the pattern. So here I have a link on the this particular slide. You all can even scan this particular QR code for opening this teachable machine. So those who are very new to this teachable machine, for them I'm just typing here in Google, this is teachable machine. I'm hoping many of you might be aware. See here, this is teachable machine. This is a product by Google. You can see in the extension of the particular website, it is with google.com. Teachable machine. So what is this teachable machine is? This is a one of a initiative from Google. We can train the computers to recognize your own images, sounds, and poses. That poses can be for like posture recognition, or kind of different yoga poses or something like that. So, without wasting time, I just wanted to show you a quick demonstration on what is meant by computer vision, how the image processing is done in the CSE domain, so that non-CSE background participants can also understand. So, here are three options you can see on the screen. First is on image project, second is on audio project, third is on post project. So even you can try on your own system. I'll just paste this link in the chat window. You all can open it. So here, out of these three options, I'm opening image project. There are two more options. One is for the standard image model and second is for the embedded image model. Now, what's here for standard image model? The standard image model, this is for color images and best suited for most of the use cases. The size of color images is 224 by 224 pixels. We have to measure image in the size of pixels. So the size of image is 224 by 224. We can export these models to the libraries called TensorFlow, TF-Lite, TF.js, etc. And the model size will be 5 MB around. The other option is embedded image model. This is best for microcontrollers for grayscale images. So we are not exploring embedded model for now. I'll just click on standard image model. Now here we are having this kind of dashboard, very simple dashboard. We can create some classes, maybe your common classes. So here are some, you can see add image samples. So there are two options. I can add image samples by uploading from here. Like we can drag and drop, we can connect to Google Drive, or we can, crop some images or something like that. So I don't have samples ready with me to teach to our machine. So I'll tell you the background to the non-CS, background participants. Teachable Machine is one of a initiative by Google or a project by Google, which teaches machine how to recognize the images, or this is a specific problem statement of image classification. We are going to classify images into different classes. So for that, I don't have any sample images with me for now. I'll open webcam so that I can have a sample images. So here I have some objects around me. The first object is this is a pen stand. So for this pen stand, I'll just hold it for recording so that this machine will start learning these images. So I'm just rotating this pen stand with multiple angles, maybe up and down and so on. So with just certain 10-15 seconds, it has collected almost 250 images samples. Now I'll give the name as this is a pen stand. Okay. Now I'll just go to the next class and I have a water bottle around me. Let me open the webcam. So this is a water bottle around me. Let me hold it to record. So with just 10-15 seconds, it will, record some images of this water bottle. I'm just moving it far away, then even very near to this camera, something like that. So once done, I'll just hold. Now I will rename this as water bottle. Now, this particular, okay, I misspelled it, water bottle. Done. Now, I can add some more classes. Let me open the webcam. And there is a one diary which is there with me. So I'll just open this webcam to hold the records now. So this particular teachable machine will start recognizing this, start collecting the samples of this diary. So around 250 images we have collected. Now I'll just give the name as diary. So I have right now three classes. You can even add more also. Here is the option to add classes. By this way, we can have some project for say disease detection. So whatever number of classes are there for any kind of image classification problem, we can use this teachable machine. Now there is something called as training. This particular AI model is training this images sample. It is preparing for training. It will take a minute. In the meantime, I would like to tell you whatever samples we have collected within just 10-15 seconds of time. We need to click on wait, that we can even download. So those sample we can call it as a custom database. That custom data set we can upload it on Kaggle, GitHub repository. We can upload it on even this IEEE data port, or there are so many such websites where you can contribute to your own data set. I'll show you how you can do that. I'll just have to click on OK button. Right. So I'll just click on these three dots you see here. We can even delete the class. We can disable the classes. We can remove all the samples also. We can save the samples. And the most important part is we can download the samples. So we can collect the samples by this particular method by opening this webcam for a few seconds, and we can collect the images. So till the time it is training the model, we will move on to the next part of the discussion. It will take some time. Till that time, I'll explain you here. Few terminologies are there. Epochs, batch size, learning rate. These all things we can customize it for our AI model. Now, what is this epoch, batch size, learning rate is about? These are all terminologies of neural network. Okay, I think it has trained the AI model. First, let us have a demonstration of the teachable machine. Then we will discuss about epoch, batch size, etc. So I'll just show the objects which are there around me to the camera. Web camera is already on. And see here, this is a pen stand. So I'll just zoom out the screen so that you can observe in one glance. The probability of pen stand is 100%. Now I'll show diary. Now it is 100% for diary. And let's see for water bottle. Water bottle is again 100%. I'll just replace it for diary and again for pen stand. So you observe this is like with longer distance, close distance, different angles. Still, it is perfectly handling 100% because it has recognized all the features of these three objects which are around me. There is ear pod with me. I'll just show ear pod. Maybe the model will get confused, or maybe it is showing some wrong output. You can see it is getting confused because I have not trained for the pen stand. I have a mouse around me. Maybe it will multiple objects because I have not trained this particular AI model for multiple objects. So it is getting confused. You can see the confidence score is less, but as compared to this is like immediately 100%. So what I'm trying to tell you that using these kind of teachable machine, this particular AI model is learning the features of images. Here are certain settings: epochs, batch size, and learning rate. So what are those? I'll just tell you. For example, I have this book with me. This book contains say 100 pages. I want to read these 100 pages, but maybe I don't have capacity to read 100 pages at once. So what I will do, I will divide the entire book into some portions. Maybe this 100 pages book I will read for 5 days. That means on first day I will read 20 pages, first page to 20 page. On second day I will read 21st page to 40th page. Then third day 41st page to 60 page, and so on. So it takes total 5 days to complete 100 pages book. So here, but I am reading the entire book only once. So what is meant by epoch? Epoch is I am reading this book only once, means epoch is once one. But reading book only once is not sufficient. Maybe I'm preparing for say UPSC examination, NEET examination. So I have to read this particular book maybe 5 times at least, 10 times at least. So multiple passes are required so that I can train with that book properly. So epoch is number of passes, entire passes. Now in this entire example, what is batch size? So here we have a batch size of 20 pages, and we have iterations, that is 5 iterations. In 5 iterations, batch size of 20 pages. In one epoch I am reading the entire book, but I am of course this reading entire book only once is not sufficient. I did multiple epochs. So here this is the epoch, right? How many times you want to pass this data set for training the model. So you can increase this count, you can decrease this count. This is called as epoch. Now, what is learning rate? Learning rate is one of a factor in what rate we can learn the particular or the features are getting learned. So, learning rate can be of different variety. For simplest understanding, I can tell you learning rate can be of like small value, mid value, larger value. If I keep the learning rate as a small value, the model will be slow while training, but the accuracy of your model will be stable. It shows you good accuracy, but it is slow because learning rate is slow. Learning rate is low. Coming to the moderate learning rate, when it is moderate, maybe it is in between, neither slow nor too fast, and accuracy is quite stable, but not as good as maybe the lower learning rate. What about higher learning rate? Higher learning rate is the model will complete fastest training, but in that case, model won't be that much stable. It will start hopping, right? So while adjusting the parameters, learnable parameters in the entire, training process. So this is the effect of learning rate, and this is a teachable machine. How it is actually recognizing all the objects, etc. Now, I'll just move on to the next part. I hope some of the participants might have gone through this teachable machine. Just want to understand the audience. This was just a ice breaking kind of demonstration. All right. I'm not able to see any comments, but that's fine. Now, I'll just close this part and we'll move on to the next part of the discussion. Yeah. So basically, when I was demonstrating this part, we were doing three things. One is I was collecting the data. It was capturing around 200 to 300 images of different classes like paint stand, water bottle, diary, or something. Then I trained the model, which is readily available there inside the teachable machine. Training of model was happening. Then live testing. So these is the three things, important things while classifying the object. Now, when I was demonstrating this particular teachable machine, there is a computer vision, and that was a traditional computer vision. Now, see, you might have seen what was the drawback of traditional computer vision. It was not able to identify multiple objects at a time. If you can see on my screen, this is really a complex image. You can see how many objects are there in the on this particular picture. You can see there are many people who are crossing the road. There are some vehicles. There is a traffic signal, maybe a market area. There are some navigation indicators are there or something like that. So this is really a difficult task. Here, what do you see in this picture? There is a lady who is cutting some fruits. There is a laptop. There are she's inside a kitchen, etc. This is a classroom. You can see why I am showing all these pictures to recognize the objects, people, things, environment in the picture. It becomes really difficult for a machine to understand. See, we have humans have a vision capability. We see the pictures at one glance. We can understand because we have seen these environments before, but for machine understands only pixels. So it becomes very difficult to understand all these pictures at once for a computer vision. So traditional algorithms won't be sufficient for processing these kind of pictures. So as we have discussed, three pictures were showing like cars, people, traffic signal, woman, fruit, laptop, kitchen, classroom, students, teacher, etc. So for our brain, we can do this job less than a second. But for computer vision, it becomes very difficult to understand all these objects at once. Okay. Now, why vision AI is important. So, we see current topic of this particular session is about. Just let me check the audience. There is someone who has unmuted. Yeah. So here we have a lot of things like organizations. Many organizations are already having these kind of infrastructure available. Like they may have CCTVs, mobile cameras, sometimes drones, medical images, satellite images, or many other such, right? So so we have a lot of data available in the form of images as well as in the form of videos. Now, using computer vision, it can detect certain things but not complex images. That's why in the today's session we are going to discuss about what is vision transformer, vision language model, and vision language action model. So let's see what is computer vision. So as I have added here in the slide, computer vision where machines can see and detect some parts of the images like we have seen the demo. Vision transformer, it understands visual patterns at the depth deeply. It can understand the context and then it shows the detection pattern, etc. What is vision language model? It understands and describes the language in language also. We will see some demonstrations. Next, vision language action model. It actually just won't understand. It understands plus takes the action in the real world. So here, the last one is very powerful. Vision language action model. It just, of course, it sees, it understands, and it takes the actions. Now, so here is the evolution of vision AI. So let's see how evolution happened in the computer vision domain. So traditional image processing is at the first level where it was just working on the pixels of images. So those pixels it was considering as a feature. Important features are captured, extracted. Not important features are removed from the neural network, and then it was able to predict kind of images, or it was able to process the images. The next evolution happened, that is CNN. CNN stands for convolutional neural network. Here it is much better than the traditional image processing. In CNN convolutional neural network, it was with higher accuracy and with many vision tasks. Now, coming to the next, this is our today's agenda of the discussion, vision transformer, which actually follows self-attention mechanism, which is better scalable than CNN. So, what is the difference between CNN and vision transformer? That we will look out after few certain slides. Next evolution happened, that is a vision language model. What is vision language model? Suppose I am passing an image of a dog and I am asking to that image, what is the image is about? The answer is coming as the dog is sitting on the grass. That means it understands the image, it answers in natural language. This becomes vision language model. Coming to the next part, vision language action model. Now here it is not just understanding, it is understanding, it is responding, and also it is taking some action in the real world. Like this robot is picking it is understanding this is a cup. Cup needs to be picked. It is interacting also, and then it is actually picking the cup. So this is a autonomous, action taking system. Now, so this is how it behaves: see, understand, communicate, and act. So detects the objects, understands the context, interacts in natural language, and takes the action into the real world. So this is how evolution of vision AI happened. So now let's move on. As everyone know about traditional image processing, how it does. So for non-CS background participants, would like to just share here. The traditional image processing is like we have to give input as an image. Image is divided into n number of pixels. From those pixels, features are extracted, then objects are identified. For example, we are showing image of a cat. Then we can ask like how does computer know this cat? So cat will be learned by computer by learning the pattern, by learning the features from the image. So that is a traditional image processing. So here would like to show you like how the image looks like actually to the computer. We can see these numbers at once. This is 6, 7, 8, 9, etc. But for a computer, it is not 6, 7, 9, 8. It is actually the input in the form of, you can see some pixel values. Those pixels value are in the range of 0 to 255. 0 represents black color, 255 represents white color. And in the range of 0 to 255, all represents gray color but shades of gray. Those which are close to 0 are like dark gray color. Those which are close to 255 are light gray color. What about color images? So here, this is actually the input image, and see the image is like combination of some pixels. Now talking about the color images, you can see this is a color image. Color image is having three channels: R, G, and B. R stands for red channel, B stands for blue, and G stands for green. RGB. So here in this RGB channel, there are three channel inputs we need to give. Now, so that was about traditional image processing. Talking about convolutional neural processing, here, as everyone knows, this is recognition of number 7. Number 7 is picked from one of a famous data set, that is MNIST data set, which is made for handwritten digits recognition. This 7 number is handwritten digit. This will be recognized via this convolutional neural network. Convolutional neural network consists of different layers: input layer, hidden layer, and output layer. On the screen, you can see hidden layers are there. This 7 number is of pixel size, say 28 by 28. 28 into 28 becomes 784 pixels. Those 784 pixels are passed through these dense, fully connected layers to recognize whether this image is a 7 or any other number. So out of these 0 to 9 numbers, probability for 7 number will be highest, so that it will be classified as 7 and not 1 or 2 or any other. I'll just play this video for a few seconds. Yes. So I think there's some noises coming up. Yeah. So you can see there is number one, two, three, something like that. So all those are recognized as the proper number. So convolutional neural network it is very good for image recognition. LSTM is very good for speech recognition, but for future videos or for complex images, the CNN is not sufficient. For example, you see here, this is a complex image. Talking about CNN, okay, just have a picture, look on this particular image. This looks a very smart classroom from a school. You can see there are multiple objects. Some students are raising hand. There is a projector. The teacher is standing just close to the students. Students are explaining something, or some. There are some things are there. Now let's understand what is the difference between CNN and vision transformer. So talking about CNN, let's just assume that we are watching this classroom from the keyhole of the class. So let's assume there is a hole to the door, and we are watching this classroom from that hole of the door, keyhole of the door. So how we can observe? We can just observe one thing at a time. Getting my point. So at a time, I can just see maybe one student, one chair, one small part of the room, like that. So that is how CNN works. So if we look out, the entire image won't be visible to CNN. It looks into parts. So it starts with smaller things and then it enlarges. So it's like we are watching this classroom from a keyhole of the classroom. That is how it looks like. Now, talking about vision transformer, if you open the classroom door, what are the things you observe? You can watch actually the things at glance. You can see teacher, student, empty seats, projector, overall classroom activity at once. So see here, the difference is CNN can see parts of the image at once. Vision transformer understand whole scene at once. How is it possible? So let's see in the further slides, but this is the basic difference. So CNN watches the things in parts, whereas vision transformer sees the entire picture all at once. How is it possible? Before that, these are some differences between CNN, means convolutional neural network made for image processing, and different about the vision transformer. So CNN uses filters. Those are called convolution filters, whereas the vision transformer uses patches. What is filter and patches? We'll see. I'll just come to the patches slide. See here. For example, we have an input image of a horse. This input image I am dividing into multiple parts. So that one part will become patch of the image. Let's assume we are dividing this image into 16 patches. So it will become 16 into 16 patches. Total patches you can calculate 16 into 16. So this is actually called as patches. So I'm going back here. Vision transformer splits the image into patches. Here in CNN, it looks at the local features first, means edges, textures, shapes, etc. Whereas vision transformer learns global relationship at once. So it has a self-attention mechanism like the transformers are having. Here in CNN, it processes images sequentially, whereas Vision Transformer processes all patches simultaneously. How the things actually happen, we'll see on the next slide. But you can look out over here. Here are the next differences. This CNN is made for smaller data set, whereas Vision Transformer is made for larger and very complex, images or videos. CNN is comparatively it is faster but lower computational and also lower computational cost. But in case of vision transformer, it of course it is also faster, but computational cost is little higher with the higher accuracy. Now you can look out at the image like how CNN and vision transformer works. So when we pass the input image here, in case of CNN, there are convolution filters, whereas in case of vision transformer, there are some patches. We are dividing the entire image into patches. Next is in CNN, we are splitting the image. See here, we are splitting the image into filters. So filters are actually scanning the images into parts. So at once we can see only eyes, nose, then ear, then it combines as a head of the cat, then maybe hands, legs, and then body of the cat, and then we can see cat at later. So this is how CNN recognize images into parts, whereas in Vision Transformer, it divides all the parts into patches, but those patches are working together. There is a transformer encoder mechanism. We'll talk about that. Then next step is about analyzing the patterns of the image. After analyzing, so here in the analyze pattern step, in case of CNN, it detects the local pattern, whereas in case of Vision Transformer, it detects the global patterns. So you can see the output prediction. So in case of CNN, it identifies cat in the image. Here also it identifies cat in the image. But in case of vision transformer, Identification of cat in the image happens all at once, not in the patches like eyes first, nose, then ears, and then combine as a head, then body, and nothing like that. So it identifies entire image at once. Now, how it happens? So before that, why we are discussing about vision transformer. So basically, most of the audience may be already aware of what are the transformers. So transformer is nothing but this is one of the best invention happened in 2017 with the attention mechanism, which everyone might be knowing. I'll just very quickly open one of a website that is attention, not website, the research paper. Attention is all you need. This is the invention made by Google team for the transformer based architecture in 2017. This particular invention made in 2017, you can see the citations are 2,60,000 plus. This actually attention mechanism understands context of the sentence, whereas but this is for generic transformer based mechanism. There is a need for a specific custom domain for computer vision. This there is a computer this vision transformers are there. So this attention is all you need, a transformer based mechanism. This is for generic things, whereas vision transformers are specific to the computer vision domain. Now, those who are really interested in understanding how the transformer actually works, so here is one demonstration. Would like to share this with all of you in the even in the chat window also. This is a demo. You can see here transformer is explained in a very nice way. You can observe this particular 3D visualization of this image. I think it is taking little time to load this part, but you can open at your end. If it works at your end, then you can just observe how it works. Let me take a minute pause. Yeah, so yeah, it is visible now. You can see here the transformer is explained in very detail. Those who are from AI background, they will understand this entire process. So here is the embedding of the word. You can expand it. How the token embeddings, position encoding, this is happening here in the embedding step. Next is a multi-head attention mechanism with key query value. So there is a importance of this query. This is called as QKV. QKV, this is a backbone of attention based mechanism. This is called query key and value. This is actually backbone of the attention based mechanism. If you see the this is you can see QKV kind of architecture. So now you can see this is a multi-layer perceptron. We are using activation function as GELU, and there are certain probabilities coming up. So here is the calculation of probabilities for the word embedding. So you can watch this particular transformer based architecture in detail. Since the sessions focuses on vision transformer, I'm just skipping this very quickly. Now, what is about vision transformers? Now here the images are, let's have a watch on this video first, then we can have a further discussion. I'll just share with audio. I'm not sure whether I have shared with audio. Just a second. Let me share it once again with audio.
Let's try to understand. Let's try to understand in a simple way. Transformers read sequences like words in a sentence, but look at this cat photo. It's just a grid of pixels, not a sequence. Or is it? Here's the trick. Lay a grid over the photo and cut it into patches, 16 by 16 pixels each. Watch the patches fly out into one long row. There's our sequence. Each patch is flattened into a list of numbers. Then a small linear layer turns it into a vector, a patch embedding. Each tile becomes a chip. One problem: attention has no idea where each patch sits. So we add a position embedding to every chip. See the numbers underneath?
All right. So let me share again. When I'm sharing with audio, I'm getting muted. So I think I'll have to share just entire screen without audio. Yeah, thanks. So here might be the audience is getting know that what is vision transformer and how it works. So here are I think I am misspelled here the numbering. This is 8 step. The answer, right? So here first step is images are not sequences. We are cutting them into patches. Then patch embedding is done. Next is once patch embedding is done, we need to add some positions so that the sequence of image will be remembered. Fifth step is there are tokens, standard attention mechanism, then global layer works out layer by layer, and the answer is coming up as we have seen in the video. Now, this vision transformer, those who want to understand much in detail, this is actually a original paper by Google Brain team. I'll just open this paper here in front of all of you. Image is worth 16 by 16 words, transformer for image recognition at scale. I'll just open this research paper, which I have already downloaded. I think you're in the downloads. Just give me a minute. Yeah, this is the research paper. Image is worth 16 by 16 words. The same paper, published by Google Research Brain Team in 2021 year. You can see this is published in June 2021 year. And there is an architecture of this vision transformer, which is displayed over here, which we have just now saw the architecture, how it actually works. There is a multi-layer perceptron head, transformer encoder, linear projection, which flattens the patches. Then it processes. So here is the architecture. Those who want to learn about this vision transformer, they can go through this particular research paper. It has, you can see there are variants of vision based transformer. It is base model, large model, huge model. Base model is having 12 layers, large is having 24 layers, huge is having 32 layers. And you can see there different number of parameters, head sizes, multi-layer perceptron sizes, and hidden size. So you can see there are variations in the parameters as well. Like in the base model, 86 million, M stands for million parameters, whereas huge is with 632 million parameters. Not only just variants, you can have the results discussion also here in the research paper. Very detailed paper is there for 22 pages. You can have a watch on this. You will get this paper immediately on Google. Now, apart from that, this Google researchers team, they have provided the code also on the GitHub repo. You can see Google research team Vision Transformer. You can get the code also available here. This is for them who want to build this Vision Transformer from scratch, or who wants to understand this Vision Transformer from scratch, like starting from installation, fine tuning, understanding the architecture, available models of Vision Transformer, etc. Apart from that, those who want to use this vision transformer based models, they can go to website called Hugging Face. Hugging Face, where we can find the repository of various AI based model. So here AI community shares a lot of models. We can find vision language model, vision transformer based models on the Hugging Face website with entire documentation, ready to use models, etc. We can just type here vision based models. You will get to know about these models. You can see these are all vision based models. In fact, you can go to models in the task. So task specific, you can see computer vision is the category. Here are different categories of computer vision based models. You can observe, like for example, for video classification, specifically developed by Google Brain Team. You can just type Google or maybe Google Brain Team. You can find the models for computer vision. See, this is which we were discussing about base, large, and all those models. So you can find the details on Hugging Face website also. Now, this vision transformers evaluation. Talking about evaluation, this evaluations is, you can see that there is a graph accuracy for specific use cases, that is depends on the data or computational investment, how you are doing it. Apart from that there are certain parameters which affects on the accuracy of specific use cases. One is prompt engineering, prompt learning, how you are doing the fine tuning for particular parameters. So parameter efficient fine tuning and fine tuning. So these are some dependencies for evaluation of these models, vision based transformer model. This slide we have already seen, but we'll come back to this slide maybe after certain demonstrations of the vision transformer. We'll first have a demonstration and then we'll go back. So here, talking about the next after vision transformer, there is next is called as a vision language model. Now, what is difference between vision transformer and vision language model? Vision transformers are comparatively older. We cannot deal with natural languages with the vision transformer. This is specifically made to understand the natural language in the videos. So let us have a demonstration first so that everyone can experience this vision language model. So I'll just share this link with all of you in the chat window. I'll just open chat window and you can explore. I'll open this website here also. So this is iNaturalist vision language demo model. I hope this is visible to everyone. Can you find this website in the chat window? All right. Now here there is a, you can see a simple dashboard is given. Here we can search whatever you want for. For example, we have certain demo queries which are listed over here. You can search anything whichever you want. Like I am searching for colorful parrot sitting on a branch. Okay. Now I'll just type here colorful parrot sitting on a branch. Now, do you want to filter it by species? Here are certain species. You can see there are some fish, animals, some reptiles, so many are there. I'm not filtering with species, I'm just putting a common query and search. Now, this will search the, uh, see, this is a natural language which I am putting here colorful parrot sitting on a branch. So, from millions of images, it is searching for images. You can see parrot sitting on a branch. Getting it? You can see even the next part, like next images. So, so many images it will come out. So it is searching from millions of images. You can view these observations in the identify. See here, we need to log in. It will take little time, so I'll not log in it. But yeah, so I had just added one common query. Let us type something different. Maybe elephant near water hole, maybe in the jungle or forest, water hole. I'm just putting this query elephant near water hole. Now let us search it. See, elephant is there near the water hole. You can observe there are some, things are coming up. Elephant near the water hole, kind of. You can even search tiger walking through the dense forest. See, why I'm showing this. This is a vision language demo model, which is working from millions of images. Understanding this natural language query, like tiger walking through dense forest. You can see tiger is walking through the dense forest. There are certain images of tiger walking through the dense forest, right? About this iNaturalist vision language demo, we can you can even Google about. So this is searching for this natural language from millions of images. So this is a best example of vision language model. By using this vision language model, we can go to the this one website of this vision language demo, and you can observe who developed this particular website. So this is teamed up by researchers from the university. You can see There are multiple universities involved, including the foreign MIT University. Even Microsoft support is also there. Microsoft AI for Good Lab to understand the potential for computer vision language model. This helps to organize and explore the observations from the nature. You can search the things. See here, it is available. It has been pre-trained or compassed with 10 million photos, and from those 10 million photos it is searching for the particular photo. You can put up any other query also, even in a specific category, maybe a particular leaves or something. Maybe we can put up something like say banana leaf, leaf sorry, or let's put something like apple, or a parrot eating apple. I'm not sure, birds eating apple we can put up. Yeah, I'm searching it. You can search in the category also. That is how you can see some birds eating apple, something like that. Anyways, so this is one of a demonstration which I wanted to show you. Coming to the next part of this discussion, so this is a vision language demo where we are putting the. Okay, so this is a project by NVIDIA. We'll have a watch on this particular project. Let me play this video for a minute. There is no audio, but I'll explain simultaneously. This is a project done by NVIDIA for the understanding of visual AI agents with vision language model. So let's see. So let me take a pause. Yeah. So here, this is a warehouse. You can see in the warehouse there is some infrastructure available, and the query is to understand unauthorized person. So the query might be like, is there any miscellaneous things happening? Then answer is coming up. There is an individual without PPE enters the warehouse, a potential safety concern. That means with this video, we can interact in a natural language as well, so that all the time it can suggest you what is happening. Coming to the next part of this video, there is a yeah, here there is a, road and there are some vehicles are passing. Now what is the queries? Identify complex and nuanced activity in the city. So so I'm so sorry if I'm clicking further, just a minute. So the activities I'll play from here. See, there is a vehicle, black color car. So black color car is passing. I'm so sorry. I think I'm making some mistake, but yeah. At the rightmost lane, we are observing this car is driving in the wrong direction on the road. Now coming to the next part. Sorry, let me play this entire video all at once. Now this is actually a environment where a small robot is moving. There are some commands, turn left, right, or something. Now this is very interesting video. Okay, what happened in this video? Let me replay this. There is a person, you can see, who is actually using the see here. See, there is a person which you are observing who has actually the access to enter, but the other person who is not having such kind of access card, the second individual is immediately behind the first person without using any key or access card. He just entered, so that person looks like an unauthorized person, which is also detected by the system vision language model. This is one of the application. The next, this is about the assistant to the user in the virtual environment. This is called as virtue vision system, which assists the user in the virtual environment for the navigation of path. Anyway, so that was the demonstration for the vision language model. There's one more use case from the RoboFlow. I'll just share this link with all of you. Then we can have a watch on this use case commonly. I'll share this in the chat window. So this is the link. We will open this link. What is this about? So this is a use case specifically for the domain. You can see inspecting telecom towers with computer vision, and this is done by vision transformers. So how it is inspecting? This is a blog for 12 minutes read. You can, and this is the latest blog in 2026 April. Just let me mute to the participants. Yeah, done. Right. So this is one of a use case of vision-based transformer. This is inspection of the telecom towers with computer vision using vision transformer-based model. So first I'll show you the video. This is just a small GIF image. There is a telecom tower and inspection is happening. So area of the inspection, wherever corrosion is inspected, corrosion is like rust on the this particular telecom tower. So how much is the rust? What is the level of confidence for that rust? Is there any necessity required for this telecom tower? Because if it because this will definitely affect in future. This small rust also affect in future. So to detect that, what is the process followed? So first I'll show you the slide, like what are the steps followed for identification of rust on the telecom tower. So workflow is very easy to understand. First, we need to capture some images. Maybe in the morning session, we had discussion about drone technology. We are using a kind of drone to take the images or videos of that telecom tower. By taking the images of or videos of that telecom tower, we are preparing the data set. Since this is a project uploaded on RoboFlow, we need to means as a part of this step, uploaded the images on RoboFlow. RoboFlow is used for labeling the images or annotation of the images. So we can label corrosion or rust regions using, there is a model called as SAM3 auto label model. We can give annotation to the images. Third step, we need to use vision transformer to extract the global image features, like it understands corrosion, cracks, bolts, cables, or entire status of the tower. This is done by vision transformer. Third step, we need to train those images with AI model. We can use some specific algorithms. Like in this case, they have used, researchers has used RF DETR instance segmentation model for detection of the corrosion. Next step is to build the inspection workflow. The inspection workflow, this is done. This is for agentic AI. So input image videos, detect the corrosion, measure the corrosion area in how much area the corrosion affected, in how many pixels, etc. It is calculating it and displaying the highlighted corrosion with the labels, that how much is the confidence score. Then deploy this particular project wherever you want to deploy it. Generate the report of corrosion detected, how much area of the corrosion has been detected, confidence score, then inspection date, site information, etc. So this is a use case. Let me go back to the website again to understand it in much detail. So here are certain steps followed. You can see collect the data set, annotate that data set with your labels. You can see how you can upload from the video captured by the drone or images captured by the drone. Then here is the labeling happen to the images. You can see there is option to auto label the entire batch or label by myself, etc. Label with the team. So there is a labeling happening with SAM3 method. Next, so here this is auto labeling. This is a corrosion, not corrosion with confidence score, etc. Next, once the labeling is done, the next step is annotation. So this is all part of RoboFlow steps. And then as we move on, you can see this will approve or reject the annotations. You can just go through this particular website which tells all the steps to do this kind of projects, and see here the final, how the model is performing. So here model visualization, like there is a 95% confidence score for the corrosion detection. There is a user interface available to upload the new images, drag and drop, paste image URL, etc. So that you can upload externally as well. And this is the flow which is followed. So you can just go through this particular website for this use case for the implementation of vision-based transformers. Now, so in this entire use case, in simple words, there is a camera which was acting like our human eyes. So camera was actually capturing the entire tower image, tower video. There is a vision transformer. Vision transformer in this case is acting like brain to understand what the image is about. Are there any bolts? How is the tower structure? Are there any corrosion? Everything all at glance. It's like our human brain. The next part is DFDETR AI based model, which is behaving like an inspector to locate or outline the corrosion activities. Next part is measurement of the module, means where is the actually corrosion area it calculates and it creates the report. That's it. Now, let's have a look on another application. This is also developed by NVIDIA. And let me open this particular application. You can see here
Hello.
the,
So in this whole, so this is a
yeah.
VLM is not used, right? Visual language, vision language model.
No, vision language model is not used, doctor. I'll just show you where is the vision language model. So, can you see this particular video here on the screen? I'm just
Yes,
zooming
yes.
it. This is a warehouse, and we are chatting with this video. Do you see any safety concerns in the warehouse? And the answer is coming up. The person is, see here, individual without PPE entered in the warehouse. That is a safety concern. So we are interacting with this video in a natural language. Here is the vision language model. Transformers are processing the entire video or images, complex videos or images all at once, not like CNN. Whereas with vision language model, we can interact with the particular environment in natural languages, like we are chatting with CCTV cameras, video, we are chatting with such images, etc. For example, I'll show you another use case which is there at the downside. Okay, what kind of chatting we can do with this video? So here are certain things, might be here are some examples. You can see this picture and we'll see what is the question answering possible on this input image. So this is a very complex input image, and you can see how VLM, vision language model, is responding. What is the question? Is there a fire truck? This is natural question asked in natural language. The answer is true. Yes, there is a fire truck. Is there fire? Answer is true. Are there firefighters? Answer is true. So in such environments where a person cannot go, it can understand the situation and can respond to the particular image or video. I'll just show you one more. See, this is a single image with stock level detection. We can interact with this image. What kind of or what amount of stock is available for a particular thing, maybe for chocolates, for some water bottles, or whatever stock is there. So this is for single image, but see here what kind of VLM can respond. So we can get, just a second, someone is unmuted. Yeah. Now we'll go back. So VLM's response is, the prompt is estimate the stock level of the snack table on the scale of 0 to 100, and here is the response coming up. The response is the snack table appears well stocked with variety of snacks and treats and something like that. So this is a response received from the
Okay,
vision
so
language model.
yeah, so
Yeah.
if we want to interact with the model, like with the vision or photographs, so then VLM is necessary. Otherwise, just for surveillance, this transformer is necessary, right?
Yes, yes. So this is actually a very advanced model where it can interact with the videos, complex images. It can recognize all the minute features also. So there is a vision language model. See, you might be seeing one more image of the warehouse video. So VLM is actually understanding the scene, and it is answering like this video shows warehouse worker in yellow safety vest. So what is happening? Worker appears to be in the process of organizing these items. and this environment is good. But here something fall down also. So here you can see the workers movement also explained in detail. This workers movement suggests that he is actively engaged in these duties of stocking and something. So everything is explained here. You can see there is a box fall down on the floor also. It is also explained. So this is VLM's response. So this is possible because of the vision language model. I hope this is much explanatory.
Yeah, thank
So
you.
basically, yeah, okay. So basically, the difference between,
Ma'am,
yeah, yeah, yes,
yeah, in fact, I have one question. Actually, I need to know VLM is like Open AI ChatGPT, right? Gemini. Likewise, Vision language model is freely available or launched so that everybody can use it.
yes, it is developed by Google. We can just search the model on Hugging Face. It is open
Okay.
source. Very recent one, 2021, is the launch of Vision Transformers. After Vision Transformers, Vision Language Model came up. After Vision Language Model, the next, very recently, Vision Language Action Model came up. What is Vision Language Action Model that we will see here? Maybe via certain examples that will be better for you to understand.
Okay,
So
ma'am. Thank you.
now, yes. So we'll come to this human analogy. Maybe after watching some certain examples on this slide will come up. You can observe there is a robotic arm. This robotic arm might be filling some cups or lifting this cup. So there is an action taken by this robotic arm. So there is a vision transformer plus vision language action model plus vision language model. So what is the difference between vision transformer, language model and action model will tell you. Transformer understands entire complex video or images all at once. Language model, with that video we can like chat, we can talk to that video in natural language, but it won't act. For action, there is a VLA. The next concept is a VLA, which can understand, it can react, and also act. So let's see this analogy here. See, understand, act. So I'll just highlight here this presentation. See is just done by vision transformers. Vision transformer, it can see the complex features. Language model, it understands the video and explains you in natural language. Whereas VLA, this is after seeing, understanding, it also explains and takes the action, whatever required action done by like robotic arm. That is vision language action model. For example, just assume that you are entering to a classroom. What happens? You see everything all at once. There are some benches, there is a board, there is watch, door, everything all at once, right? So our human brain recognizes all the people, chair, board, everything all at once. So this is done by vision transformer. Next, brain understands the situation. It starts interacting with people. Like brain may say, like this is a classroom, a lecture. Lecture is about to happen. People are here to learn. I'll start maybe teaching or something like that. This is done by vision language model. But now you want to decide where I can sit. So it is acting that it will decide which is the most comfortable place to sit or etc. This is done by vision language action model. It has actually taken the action to decide where you can sit into the entire class. Now, with this human analogy, I'll just demonstrate few more examples so that it will be easy to understand. So there is an image. It is understanding the entire platter. It is picking that object and placing that object. So this is a vision language action model. Action is taken by this robot. Now, we'll just have a quick video about vision language action model, how it is performed. This is moreover in the robotics domain. I think this video is, yeah, here it is appearing now. So picking the wire for charging or maybe for connections of some device, and it is connecting it. So this is understood the picture of wire, where to put it inside that hole. It has understood and it has taken that action also. This is a VLA. Now coming to the next example, moreover, with your CCTV, we this is not just to record the video, but nowadays with vision language action model, what is all possible? Actionable intelligence, what is all possible? Let's see via this video. So basically, vision language action model analyzes the live camera which you are feeding. It can count people, it can monitor the crowd movement, it can track the vehicle's flow, it can understand the restricted areas. If there are any safety concerns, it can also understand. So this is so I hope getting the point. So via this CCTV video, there are lots of possibilities are there. So vision language action model supports for data driven decision making thing. So for the smart cities, these kind of vision language action models are much necessary in the organizations. So here are certain points which I mentioned on the slide. Now I'll just move on to the next part. So this is not just for CCTV. Even this vision language action model can be performed in some hazardous situations like here. We can see it is very becomes very difficult to enter into such areas where the this kind of drone is capturing the video, and it can immediately prompt to the operators that what is all happening, where is the fire, what level of fire, something like that. So, natural language feedback in certain, dynamic situations, it can handle with the understanding of emergency conditions. So, this is not a just a general picture, but this is in reality there is a project called as Horse Eye. Let me show you. Let me keep it. We'll make it full screen. So there is a project called as Horus Eye. I'll just show you this particular article on the internet, and we'll open this archive. Now we'll just share this link with everyone in the chat window. Here is the research paper. So this is a particular project done by some researchers. This is for language as a dynamic attention for emergency visual analysis, and very good research paper draft is there. Which, if there are certain number of researchers who have joined this session, they can go through this paper. But in short, about this paper, let me share something on this presentation slide. So here, this is a framework which researchers has developed, which is evaluating the natural language for the dynamic attention-based mechanism for certain emergency visual analysis. So now let's see. In this entire research, they have used the researchers have used a popular benchmark dataset. Name of dataset is REF COCO. So COCO is a base dataset, and REF is a specific data set. We can just Google out and you can see this is available on TensorFlow, this is available on Hugging Face, and available on Kaggle as well. So you can get this data set very easily. I have also included the website link for Kaggle. You can just get this data set on Kaggle as well. So this is a benchmark data set which can be used for visual grounding or kind of such projects, right? Now, in this entire project, I have just added a few explanation about this project. So here, this data set consists of total 15,000 plus images with base images 3,000 plus with certain conditions like foggy situation, smoke situation, clean situation, thermal images, etc. Now, what are those situations? I'll show you here on the next slide, like how the clean situation looks like, fog situation, smoke kind of situation or thermal situation. So all kind of situations are very important, because in emergency condition there will be sometimes smoke, thermal situation, fog, etc. So now, here in this project, there are certain models are used. You can see Queen version. This is model available on Hugging Face as well. This is available in different sizes. Like, you can search this model on Hugging Face website. I'll just show you. Uh, Let me go to Hugging Face, and we'll show you about this Queen model. Here is that. We can just quickly go to models, and we can even search here in the filter as well, or let us type it, Queen model. See here, there are certain versions of the Queen model. In that project, second version was used. These are all open source models. See, whatever Hugging Face is providing, these are all ingredients of the AI model, AI software. Using models, data sets, space to execute. These are all ingredients of the software. We can prepare custom software for our own project. Now, so these are certain things about that project. The metrics are base images, certain conditions. Four kind of conditions are tested: clean condition, foggy condition, smoke, thermal, etc. Total images 15,000, and there are certain some more parameters which you can see. Not only for tower inspection, not only for CCTV, not only just for this kind of emergency conditions, but this can also be used for medical image analysis. About vision transformer I'm talking. Vision transformer can also process medical images from picture to diagnosis. You can see it. This particular diagram is generated by AI, but it is done in 8 steps. Input medical image, pre-process that medical image, patch extraction, which is the role of transformer based mechanism, vision transformer, patch the extraction, patch filtering, embedding, token sequence construction. If we look out the entire process, then we may understand, like, for such complex images of healthcare related diagnosis, medical images, how it can do the things very well in multiple steps. So vision transformer can be used in medical images for brain MRI analysis, cardiac image analysis, histopathology, retina imaging, robotic surgery, skin lesion analysis, chest X-ray analysis, etc. So that means the vision transformer converts all these kind of images, whether it is MRI, X-ray, or whatever from the medical domain. It converts that image into sequence of patches, uses self-attention based mechanism. It understands the relationship between all the tokens of that image. Then it diagnoses the particular task, whichever you are using it for. And it also can be integrated with some of the explainable AI system for interpretation of your results. So basically, which AI model is used? So here, for image classification, basic CNN or vision transformer we can use. For medical report generation in the natural language way, we have to use vision language model. Medical image question and answering system, again vision language model. But for the next level, see, I'll just highlight this particular presentation. Just for classification, transformers are there. For report generation, question answering, language models are there. But for taking certain actions like surgical robot assistance, vision language action models are there, VLA. So this is at like preliminary level, moderate level, and this is like third level in the domain of vision transformers. It is not just only in the telecom domain, medical domain, or CCTV surveillance, manufacturing industries, but there are so many areas where these certain things, vision transformer, that is VIT, vision language model, that is VLM, and vision language action model, that is VLA. All these three things can be used in varieties of domains, like in the autonomous vehicle for lane detection, traffic signal recognition, pedestrian detection, etc. It can also be used in the manufacturing domain for defect detection, predictive maintenance, quality inspection, etc. Remote sensing, land lower classification, disease monitoring, crop health analysis. So many areas are there in the retail industry, Like we have seen one of the example of inventory, how it was organized, what was their stock present on the shelf, etc. So shelf analytics, inventory automation, even in case of security, face recognition, anomaly detection, smart surveillance. These are certain real world applications of these three: VLI, VIT, VLM, and VLA. Now, before I proceed ahead, there was one question: where can we find these models? So there are lots of vision language based models are there, which are all open source, which are all recent one from 2021 to even latest. There must be few models in 2026 as well. You can see some there are very good organizations, or we can say big organizations like OpenAI, Salesforce, some universities which are reputed universities, Microsoft, Google, Alibaba, OpenAI. They have provided their own models for the vision language model. You can see OpenAI's Clip model, Salesforce Blip model. You can see there are some more like by DeepMind, Flamingo, Microsoft Cosmos, Quane, which we have just now seen. Quane model is used in the previous project here. Here the Quane model is used. You can see this is a Quane model for emergency situation understanding. Gemini by Google, GPT-5 by OpenAI. These models actually very well suitable for multimodal reasoning and image understanding. These are certain data sets for vision transformer. These are all available open source. If you want, I'll just show you, like, say, let's take an example of CFAR 100. What is that data set? Let me just discard this presentation and we'll go to
Some models
search.
yeah, excuse me. So some model are name same as LLM, like GPT-5, Gemini 2.5.
Yeah,
So is it a some
yes.
same way we are using like LLM and VLM together?
Yes, they have upgraded their previous version, like GPT-4 is upgraded with vision language action model. So they made it custom for even video also. They call it as a multi-model reasoning. Multi-model means it can process audio, video, signals, text, numbers, and any other kind of any even geospatial images, etc. So though it is a name is same, but this is a vision language model. GPT-5. We can search about this. So these are some famous vision language models. The names are same, like Gemini's 2.5. This is made for even vision purpose. And there are
Ma'am,
certain custom models. Yeah, please.
yeah, one request. I'm
Yes, sir.
finding this presentation very useful because I'm working the same area. So I would like to
Okay, sir.
take this PPT if you can share.
Sure, sir. Sure. I'll share this presentation with everyone. No
Thank you,
issue,
sir.
sir.
Thank you, ma'am. Thank you, ma'am.
These are certain data sets which I wanted to share, like those who are researchers working in this domain. Few data sets are, we can call it as a toy data set, just for understanding of how your, or we can call it as a benchmark data set. By using this benchmark data set, we can test our model, then we can make it custom for specific purpose. Okay, for our own organization, for specific clients requirements or something like that. So these are some benchmark data sets which are totally freely available. You can just search even on Google as well, you will find this data sets. Let me go on Google and type here CFR. There are two variations of CFR, CFR 10 and CFR 100. These are all benchmark data sets. CFR 100 consists of 100 classes, 32 by 32 color images, 60,000 images. This is for 100. You can get it easily on the website on Kaggle or University of Toronto's website, which is the origin of this data set. So, anyways, these are for vision transformer. This is for vision language model. You can see MS Coco caption model. And you can see the last one, which we just saw. The last one, REF Coco, which was used for emergency situation benchmark data set. This is a grounding model. Apart from that, suppose you are developing a project, maybe interview question answering system, or that is a virtual interview question answering system. So there is a visual question answering system. You can use this particular data set for as a benchmark. VQA version 2. Just Google, you will get it free of cost, like on maybe on Kaggle, Hugging Face, or their original website, etc. Apart from that, there is one demonstration is prepared just to show you how it works in practical. Let me open this particular website in Google Chrome. Then we'll wind up this session on time. Yeah. So this is prepared for understanding of vision transformer explanation, how it actually works. So this is the exact architecture available on the original this from the research paper, original research paper, which we I think just some time before we had discussed. Anyways, so here we have to input the image. It will patchify into 16 by 16. It will flatten the image. First, we'll have a demonstration. Then we'll go through this entire architecture. So there are certain images you can see. There is an image of cat, dog, parrot, etc. at the corner. We can even upload certain images from the computer as well. Let me open one sample image of a cat. Sorry, not the cat, dog. So let me go to stages. So here it is actually picking up. We can even upload any other image also. Let me take this image. So this is the image of a dog, and let me play. So there is a model configuration. We can increase the patch size, decrease the patch size, etc. We can increase the num head count, etc. Okay, first let's have a watch on how it actually works. So let me play it for all of you. This is the input image, which is patchifying into 196 patches. Those patches are flattened. Now there is a position embedding. Position embedding is to remember the sequence of patches so that it will recognize, it will run in loop. Patchify, then flatten all the images into multiple vectors. Position embedding to remember the sequence of those vectors. And it is identifying this is a tabby, maybe dog or cat. Yeah, dog, something like that. Now you can even upload certain image from the, let me just open one of the picture. Maybe there's a butterfly. We'll open up and let's see how it works. So it is patchifying into 196 patches. Let me reduce the patch size. See here. Okay, so this is how it is working. I'm not sure how many of you have understood this entire process, but if we look out at the pipeline, this pipeline is very clearly explaining the input image. Patchify means we are dividing the entire image into whatever patches we have, decided here. It is dividing into patches. Then flatten means every part of the image that becomes a patch we are flattening it into a single dimensional array. Then we are embedding all the patches. While embedding we are putting the sequence also. So for putting the sequence, which patch comes after which, to understand that sequence, there is a CLS. CLS is the first zeroth class. To this zeroth class, all the positions of the next patches will be recorded, so that it remembers the sequence of patches. Then inside this is actually the transformer, where the entire mechanism of giving attention to every patch is happening all at once, so that entire image will be understood when it is fed into the network. So this is architecture which is exactly same as the architecture published in the Google research paper. And then classification here to classify that image or prediction. So last part is the prediction. We can observe. So this is the pipeline. Anyway, so that was just the last part. So the before I wind up, the key aways from the session is vision transformer. It learns entire image all at once, not like CNN. CNN learns the image one part at a time. Here, it learns entire image all at once using the attention based mechanism. This is same transformer based mechanism made custom for vision domain. What is vision language model? It understands the image and answers the questions in natural language. The next Next level is taking the action. Just won't learn and understand. It learns, understand, plans, and perform the action, like robotic arms are taking that. So there are certain applications are coming up, like intelligent assistants, autonomous systems, robotics, etc., where combination of all these are together. VIT, VLM, and VLA. These are all happening together. So that's all about, and this is my email ID. If you